Good morning, friends. I am Dr. S. Veeramalai, Professor, Department of Computer Science and Engineering. Today, we are going to discuss about data mining concepts and techniques. So, under this title, we'll discuss about why we need to have data mining. What is exactly data mining? What is a multi-dimensional view of data mining? What kind of data and pattern can be mined? What are the technology involved in data mining concepts? What kind of applications are targeted in data mining? And what are the major issues in data mining? And finally, we'll have discussion on history of data mining as well as data mining society. Okay. So first we'll discuss about why data mining. Okay. So when we have a large amount of data, okay, so identifying or understanding that particular data is or the interesting data is very difficult. So here you can see the explosive growth of data from terabyte to petabytes. Okay, how this data can be collected. Okay, so data collections and data availability will be done automatically by using some tools and data management systems, web computerized societies. The major sources of data will be taken from business, science, and society on and everyone's. Okay. In case of business, will be web, e-commerce, transactions, stocks, like that. In science, remote sensing informations, and bioinformatics informations, and scientific simulations. Okay. We are drawn in data, but starving for knowledge. Okay. It is clear givenly necessity is the mother of invention. Data mining, automated analysis of massive data sets. So, the next one is evolution of sciences. In before 1600, it is empirical science. So, whatever we have a data, everything will have evidence also. So, based on the evidence, okay, they will have some experiments and they will inform us uh, truth about the materials and realities, including biological nature of a man. In 1600 1950s, it is a theoretical science. Okay. We have large amount of data. Everything will be discussed and analyzed, and theoretically will have large amount of theoretical component. So through theoretical analysis, we will try to have some understanding. Generalize, we will have some understanding. uh, that understanding will try to motivate us to do some experiments. And 1950s 1990s, it is a computational science. Okay, there it is combined. It is a computational science that traditionally mean simulations. It grew out of our inability to find closed form solutions for complex mathematical models. We have some data. The data we may not be able to identify or we may not be able to understand. Okay. So for those, we'll try to have some mathematical model. Through some mathematical model, we'll try to understand the data. Okay. And finally, data science. It's a flood of data. All the data may be collected from some science using some scientific instruments. When you have a data, if you do some process with the help of scientific instruments, okay, we'll be able to get large amount of data. Okay. When you do some simulation process, there also will be able to get large amount of data. Okay. All the data will be collected, okay, and will be analyzed, and finally it will be the interesting patterns will be identified. So it is 1990s and now. And next, evolution under and the continuation of evolution of database technologies. 1960, okay, we have data collections, database creations, and information management system and network DBMS. Okay, It is evolutions. In 1960s, we have data collection, and collected data will be stored in a database. So we are going to create a database, and from this database, we will try to have some informations, that the collected information can be uh, given through networks. Okay. In 1970s, it's a relational data models. Okay. You know very well relational data models. Okay. The relational data model, in the sense, the collected data will be stored in the form of relations, tables. Okay. And the table form stored data can be analyzed, can be processed by using database management systems. It is a software. And 1980s, okay, it is a relational database management system we developed. Okay. It is advanced data models. Okay. So there we will have all kind of data. There we have all kind of data. Okay. Like a spatial data, scientific data, and engineering data. In 1990s, we are applying data mining concepts, data warehousing, multimedia database, and web database. Mhm. So these are all the concepts. These are the evolution of database technology. And in 2000, we have taken a stream of data, stream data management and mining, and data mining and its applications. Then web technology. These are all evolution of database technologies. And next we will go for what is data mining. Exactly how it is going to be defined. Okay. So all we know very well, okay, data mining is we have a large amount of data. From that database, we are going to extract the interesting patterns. It will be non-trivial or implicit or previously unknown and potentially useful. Okay. So it can be any type of things, data. Okay. So the mining, in the sense, extracting of interesting patterns or knowledge from huge amount of data. Data mining is nothing but misnomer. And the data mining will be called in another names knowledge discovery. Okay. It's a knowledge discovery in database. Okay. And it's a data extractions. And is everything is data mining. So when you try to extract anything from the huge data, it is a data mining. Okay. To extract the interesting pattern from huge data, obviously we have to apply some queries. Okay. So it is nothing but it's a query process. Okay. And we'll try to have some expert systems. The expert system will help you to extract, okay, that what genuine or exactly what we mean. Okay. And next one, this is a knowledge discovery process. Simply, it will be called as KDD process. So this can be explained from bottom. You can take the bottom, it's a database. Here we have multiple databases. All the database will be it is taken from different sources. Uh, all will be integrated, and there it will be collectively stored in data warehouse. In between, the collected data will have data cleaning. So initially, we will try to have raw data. The data will be either partial data or full data. All the data, collected data, will be undergone for data cleanings. So data cleaning will help you to get the cleared or completed full formed data. The full form data will be stored in data warehouse. And data warehouse, you know very well. Okay, there the data will be stored in organized manners. Okay. And before going to store the data in the data warehouse, the data will be categorized or organized. Then it will be stored in the data warehouse. Okay. So there it is just like a fridge. There you can take, okay, potatoes, tomatoes, okay, some vegetables, some other vegetables. Everything will be categorized and it will be stored in different locations. Why we need to have a data warehouse like this? Okay, when you apply a query, okay, it is nothing but a task relevant data. When you apply a task, a query, okay, you will be able to take relevant data at maximum speed. Okay, so that will be done in data mining. Okay, it's a data mining process. Okay. So data mining is nothing but mining data or mining interesting pattern or extracting interesting pattern from huge data. Okay, and the mined data, finally you have to evaluate the pattern of the pattern. Okay. So final process is pattern evaluations. Mm. So the pattern evaluation, in the sense, we collected some data. Okay, the data collected based on what? Some patterns. Okay, so that will be discussed in the next slide. Yeah. See here, you can see, if you, as an example, if you take a web mining framework, there we have lot of process, all the process coming under data mining. See, for example, first one, okay, data cleaning. Okay, in the web we have lot of sources. From all different sources, data will be collected. Okay, and the collected data will be cleaned. It's a data cleaning process. It's a pre-process. Okay, what do you mean by cleaning? Okay. Cleaning is removing unwanted data, okay, removing partial data, okay, collecting finalized data. Okay. All cleaned data will be integrated from multiple sources. Okay, and the multiple sources data will be stored in a single place, that is in the word warehouse. So warehouse the data. You need to warehouse the data which is collected from different sources, and the warehouse data will have dimensions. Okay, if you take a cube, for example, the cube will help you to define, okay, a different pattern or different characters of a product. Okay, for example, if you take a product, some medical product, so one side there will be what how to apply this medical, this what this ointment or some tablet or something. Okay, the other side, what is the advantage? The other side, what is the ingredients? So like that, if you take a data in the form of cube, you will be able to know or understand completely about the particular data. So everything will be available there itself. So to understand the data will be constructed as a cube. Okay. And the next one is data selection for data mining. So which data going to be mined? So data must be data selected. It may be image data, it may be audio data, it may be text data, it may be video data. So which data going to be uh, uh, taken for data mining process? The next one is data mining. You know very well, data mining is nothing but extracting interesting patterns, okay, from huge data. It's a data mining process. And the collected or the mined data will be presented. Okay, you have taken some data that should be presented in some form by that. The others will understand, okay, this is the data. Okay. If you take this data will be in this form. Like that, they will understand. And finally, from those pattern, what is the knowledge going to be discovered? Okay, for example, if you take a patient, okay, he is going to give some symptoms. He is going to tell something, some symptoms. From those symptoms, they are going to have some test. Okay, from those tests, they are going to have some data. From those data, they are going to discover some knowledge. Finally, knowledge in the sense, finally, okay, this person is affected with some issues like malaria, okay, so jaundice, like that. They will try to understand or discover the knowledge from the selected patterns. So next, the data mining in business intelligence. In business intelligence, how the data mining process will be constructed. You can start from bottom. So D right side you have given DBA, something but database administrator. So database administrator will take care of data sources. So initially we need to collect data. So data will be collected from different sources. It will be paper or file or web document or scientific experiments or database. From different sources, the data will be collected and the data will be administrated by, okay, database administrator. Then next, the database collected data will be undergo to data pre-processing, it's nothing but the cleaning process, and then integrate. All the data will be integrated. Then integrated data will be warehoused. Okay. Next, with this warehouse, they will do some experiments, statistical summary, querying and reporting. Okay, so we'll have some summary, and will by applying some queries, okay, we will be able to get some data that will be reported. Okay, and next one is it's the main thing, data mining. Okay, it's a central process. Okay, so data mining is nothing but information discovery. Okay. So now we have large amount of data. The data will, from those data we are going to extract some interesting patterns, which is going to be given for further experiments to discover knowledge. Okay, and mined data will be presented in some form. By that, the people will understand, or the machine will understand, or the experts will understand. So the system will finalize in which form the data should be presented. Next one is decision making. So finally, with these presentations, we have to discover the knowledge. Finally, what was happened? Okay, that must be discovered. It is a decision making. And next one, it is a KDD process, a typical view from machine learning and statistics. The same process in different form. Okay, we can see input is a input data. The first process, data pre-processing. Okay, so under this we have data integration, normalizations, and feature selections, and dimension predictions. Okay, so collected data will be pre-processed, and then it will be integrated, then it will be normalized to be a, why we need to go for normalizations. Okay, normalize, by using normalization process only you can make it as a good database. And then feature selections. Okay, then dimensions predictions. Okay. The next stage, data mining. So here only we are going to extract the interesting patterns. Okay, and identify the patterns. The interesting pattern will be taken. Okay, it's a pattern discovery, and with this, what are the association, correlations, okay, and classification, clustering, and outline analysis. So everything will be done in the data mining. These are all data mining process. Data mining process, and after that data mining process, okay, the pattern must be evaluated. Okay, so from the data mining process, we found some pattern. The pattern must be evaluated. Okay, it's evaluation, and pattern will be selected according to our desire. The pattern must be selected, and interpretations. Then pattern must be visualized. Mm. So this is another form of KDD process. And if you take a medical data mining, okay, you can take a healthcare and medical data mining, often adopted such a view in statistics and machine learning. Okay. So same way, okay, the medical data will be collected and pre-processed, and the pre-process, okay, which include feature extraction as well as dimensions reductions. Okay. When you do pre-process, automatically dimensions will be reduced. Okay. And same way, the features will be extracted. And next one is the classifications. So data will be classified based on some parameter, and same way data will be clustered also. So either one will be done. And next one is post processing. So post processing is nothing but the pattern evaluations. Next one is multi-dimensional view of data mining. How the data mining data will be viewed in multi-dimensional. This is going to be discussed. Next. Now we can take this. So multi-dimensional views. This is, you can take the main topics. Data to be mined, knowledge to be mined, techniques utilized, applications adapted. So first one, what data going to be mined? We have to decide. Okay, and the data which is going to be taken from where? So that also should be mined. See here, database data. Okay, so what type of data? It may be extended relations, object oriented data, or heterogeneous data, or legacy data. Okay, another one is data warehouse and transactional data, stream, spatio-temporal time series, sequence, text, when web, multimedia, graphs, and social and information networks. So first of all, we have to decide what data to be mined, which data we are going to take to be mined. Okay. And next one, knowledge. What type of knowledge you are going to mind. Okay. So based on, if you have the knowledge is nothing but here, based on the characterization, based on the discriminations, based on association. If you take any data, the data will have characteristics. Okay. So based on the characteristics, you can find some knowledge. Based on the discriminations, you can differentiate. You can differentiate. Okay. So by using discriminations, you'll be able to find out some knowledge. And association, you can take a product. This product, how it is associated with some other product. So based on that also, you can find out the knowledge. And classification, clustering, okay, and trend deviations, outlier analysis. When you go for clustering, okay, there we can apply the outlier analysis, and descriptive and predictive data mining. Descriptive and product predictive data mining. When you take anything, okay, that will if you apply some task, the task itself will describe about the data or what we are going to do with this data. So everything will be described by the task itself. But in case of predictive data mining, on the way it is going to be described. It's a predictive data mining. And next one is multiple or integrated functions and mining at multiple levels. The same process, it must be in the multiple levels. You can apply mining technique. Okay, so there you can do some pre-processing technique. So first level pre-processing, second level pre-processing, third level like that you can have first level clustering, second level clustering like that you can have first level classification, second level classification like that you can have multiple levels. And the other one is a technique utilized. So what type of technique we are going to utilize in the data mining process? We see here data intensive, data warehouse, okay, machine learning statistics, mm, and pattern recognitions, visualization, high performance, etc. These are all the techniques which is going to be utilized in data mining process. And application in where we will apply this data mining. Okay, see here retail business, telecommunications, banking, fraud analysis, biodata mining, stock market analysis, and text mining and web mining. Everywhere, these are all the applications where we will apply data mining process. And next one is what kind of data can be mined. Mhm. So we'll discuss about this one. And see here what kind of, before going for data mining, we need to identify, I told you we need to identify data. So what type of data going to be mined. So we have to select it. See here database oriented data sets and applications. Say the data may be either relational data or data warehouse data, or transactional data. Okay. The data will be taken from either relational database or data warehouse or transactional database. Okay. The advanced data set and advanced applications. Okay. These are all data stream and sensor data. Data stream of data will be able to take. Sometimes we will take stream of data or sensor data. Sometimes we will take time series data. Time series in the sense, okay, is a periodical change in the data. Those type of data will be taken. And temporal data, okay, time based data. When you store any data, the data with some timing will be stored. For example, some period, for example 1960 population will be like that, 1970 population will be like that. It's a temporal data. Data, the time relevant, time based. Okay. In case of time series, there will be some periodical changes. You will have some what periods, what interval, time interval. But here, even though it's a time interval, it is not necessary to have constant time interval. Okay, it's a temporal data. And sequence of data, it is also coming under time series. It is one after another sequence of data. So 1960, this is the data. 1970, this is the data. 1980, this is the data. Like that, you can have some sequence of data. Okay. And structured data, you know very well, structured data, structured and unstructured. Mhm. And graph, you can take graph based data also. Social networks data we can take. Multi-linked data we can take. Object relational database. Object relational is a database in the sense you have data as well as object. Okay, so when we store data, sometimes we need to have object relevant to the particular data. Mhm. And you have some heterogeneous data. Heterogeneous in the sense you have different types of data, maybe audio data or video data or text data, heterogeneous, different data. And legal based data, legalized data. And spatial data, it's nothing but space relevant. You can have some angles, directions. Okay, if you rotate, it will give some other information. If you what if you change the angle slightly, it will have some other information. Yeah, later. Spatial data, spatio-temporal data. Even though it is a spatial data, there also you have some timings. Spatial temporal data and multimedia data, you know very well, audio and video. Okay, text data, simple text. Okay, and web data, world wide web. Okay, web page data. So these are all different types of data which can be taken for mining process. Before going for data mining, we must know what kind of data going to be mined. Okay, so from these you can select any one of the data. From there you can extract the interesting patterns by using data mining concepts. The next one is what kind of pattern can be mined. Okay. Now, previously we have selected data. From those data, next what kind of pattern going to be mined? This is the next one we'll discuss. See here, when we take a data must be, okay, generalized data. Okay, is first function. Data mining function. This is generalizations. We can take a man. This is generalizations. The man is a clerk. It is not generalizations. Okay, so we have to generalize the data. Information integration and data warehouse constructions. First point is information integrations and data warehouse construction. You have different informations. All the information will be integrated, and this integrated information will be warehoused. Okay. So that is there are the sub points we can take: data cleaning, transformations, and integration, and multi-dimensional data model. Okay. Next one is cube technologies. So when you construct a cube, you'll be able to scale your product. You'll be able to scale your data. Okay. So for scaling, for materializing, okay, we need to construct a data cube. The other one is OLAP, online analytical processing. Okay. This completely is online process. So when you start to do some data mining, you can take online analytical processing also. On the way, what are the data going to be collected? Okay. So in the same way, we are going to apply data mining process, and you will be able to extract the interesting patterns. The other one is multi-dimensional concept description. I told you, okay, if you take a data will have different characteristics. Okay, so characterizations will be done, and discriminations also will be done. Well, based on that, you will construct a multi-dimensional data. So the same thing, the last one you can see. Okay, if you take what can generally summarize and contrast data characteristics. Example, dry, wet regions. If you take a country, how the country can be identified based on the climate. Okay, it's a character based on the climate, based on the area, based on the directions. Okay, so it will be characterized. And see the next one is frequent patterns. Okay, frequent pattern items. Mm, item sets. Yeah. So what item are frequently purchased together in your Walmart? For example, when you go and purchase any product, so along with you will try to purchase some other product also. Okay, here they given diaper and beer. So diaper is associated with the beer. Suppose if you go and purchase a diaper, along with you may you may have a chance to purchase beer also. So what is the support, what is the confident? Okay, this is a pattern, is a kind of pattern analysis. Okay, so we have to have some kind of analysis over here. Our strongly associated items are also strongly correlated. Okay, these are the questions we have taken here. Okay. So we'll see one by one. And classifications and label predictions. You need to have a model to construct a model based on some training examples. Okay, and describe and distinguish classes or concept for further predictions. Okay, so if you have a data, the data must be constructed as a model. Okay, once if you define as a model, okay, then you'll try to find out what the interesting patterns. Okay, to construct a model, okay, we need to have some kind of data mining algorithms like a classification or clustering like that. So based on some characters, based on some discriminations, okay, we may create a model, from construct a model, from those model you can predict some things. Okay. What are the typical method we have used over here? Is given here: decision tree, naive Bayesian classifications, support vector machines, neural networks, rule based classification, pattern based classification, logistic regression, all are classification based algorithms. Okay, so when you have a large data, the data will be classified based on some parameter. You can take, we have different algorithms. In each and every algorithm, they have taken some parameter. Based on the parameter, the collected data will be classified. Once if you classify, then easily you can predict the unknown label. Okay. The other one typical applications, okay, where we are applying exactly. You can state credit card, fraud detections, direct marketing, and classifying stores, the disease, and web pages. These are all the application where we are applying, okay, this classification techniques to predict some things. Okay. So what type of fraud detections? What type of fraud persons? What type of direct marketings? How to identify the what the diseases? The diseases you are being given. How to identify, classify the stars. So the next one is cluster analysis. So it is also coming under data mining functions. It's unsupervised learning. Okay. It is nothing but the class level is unknown. Okay, unsupervised learning in the sense, okay, it is unknown. Without having anything, we are going to learn something from the data. So group the data to form a new categories. That is a cluster. Example, cluster house to find distribution patterns. Principles. Okay. So cluster, basically cluster analysis in the sense, based on some parameter, uh, you you can cluster the data, maybe height wise or size wise or color wise. You can cluster the data, okay, and there may be some variations. The variations will be identified based on the distance. This is nothing but mapping or matching. Okay, so how much percentage it is close to this particular original data. So based on that, you can cluster the data. By clustering data, you can do some predictions. It is also one of the data mining functions. Okay. And the outlier is coming under clusters. See here, a data object that does not comply with the general behavior of the data. You can outline the analysis in the sense, you can take a circle, there you have lot of data. Okay, data inside the circle will have similar will have similar characteristics. Uh, data which is there in the boundary, even though having some similarity, it is far away from the original similarities. So the percentage of the similarity will be very high. Okay. So based on the similarity percentage, okay, this will be clustered. So if you take any data, the data will have, okay, correct data, partial data, or some more irrelevant data also. These data will be identified based on the outlier analysis. Okay. So through outlier analysis, will do cluster, okay, and through cluster will have some predictions, and we can stop this class at this level. Okay. So tomorrow we'll discuss about the time ordering and sequential patterns. So thank you, friends. Have any queries, please uh, put put in the comment box. We'll try to rectify all those things. Thank you, friends.